This video we're just going to introduce the trigonometric inverse function rules for first recall the derivatives. Okay, so the derivative of arcsine of x, remember this is the same as arcsine of x, so sine inverse is the same as arcsine of x. So if you see that, don't get too concerned. Arc just means you're talking about the inverse. It's 1 over the square root of 1 minus x squared. Secant inverse, 1 over x times the square root of x squared minus 1. So the x's are next to each other. That's kind of how I remember it. And then the derivative of arctangent or tangent inverse is 1 over 1 plus x squared. Very important to remember those three there. The reason it's really just these three you have to remember. When you take derivatives of c functions for trig, remember they're negatives. C is for the negative. And so it's literally the exact same as the sign, except for I pick up that negative going on right there. Okay, so negative 1 over a square root of 1 minus x squared. And then cosecant inverse derivative is negative 1 over x times square root x squared minus 1. So the only difference here for these three is that with the c's, they're negative. Okay, so however you want to memorize that, I don't care. But that's how I remember it. I just remember these three here. And then I know that whenever I take derivatives of c trig functions, I'm going to get negatives. Now, that was what I was recalling you to remember. So now I want to go the opposite way and do integrals for arc trig functions. So what's going on here? I want to take the integral of 1 over the square root of a number squared minus x squared. So this looks a lot like this first one here because I don't see any x's out to the side, and I don't have a radical right there. So it's really got to match up with this one here. So yeah, you guessed it, the integral of this has to deal with the sine inverse, but there's a difference here, and there's a 1 here, and there's an a here. So whenever I do this, I have the sine inverse of x over a, well, that was a loud lightning, and then plus c. Okay, so that a factor there comes into play. So like if I had like the integral of like 1 over square root of 4 minus x squared. How would I do this? Well, first I would convert this to be 1 over the square root. So how do I make this an a squared here? Well, to get 4, I do 2 times 2. That's 2 squared. So my a here is equal to 2. So that means in my formula, this is equal to the sine inverse of x over 2 plus c. Okay, so this is how you would use the formula here to help you get the answer. Now, I'm going to want, if I say show your work, I'm going to show you how to do this with a u substitution in just a little bit. Okay, so not this video, but I'm just introducing it here for you. The next one is if I have 1 over a number squared plus a x squared, right? So 1 over 1 plus x squared, this is the one that fits that closest. And so, yeah, I'm going to have some form of arctangent here for my answer. And so this one's a little bit different because it has this coefficient of 1 over a out front and this x over a inside the argument there. So that comes into play because of the chain rule and whenever you use a u substitution. So if I had like 1 over, let's say instead of a perfect square, it's like 17 plus x squared, right? Well, how do I get a now? Because a squared is equal to 17, but 17 is not a perfect square, but I can still square root this thing. So a is equal to the square root of 17, right? So this would be equal to 1 over the square root of 17 times the tangent inverse of x over the square root of 17 plus c. Now, once again, this answer is not going to be any good if I say, show your work and use U substitution. I don't want to just see the final answer here. I want to see the work and U sub. So that's what I'll be expecting, but you can at least know like what the answer should be whenever you run through the homework. Okay? This last one here matches up with the secant, and this one here has the x here and the x squared inside the radical, and so this is going to be 1 over a secant inverse of absolute value x over a plus c. And so if I integrated something like this where I had x over square root of x squared minus 9 dx, I would say here, well, a squared equals 9 means that a is equal to 3. And so this gives me 1 over 3 secant inverse of absolute value x over 3 plus c. Okay, so that kind of gives you an idea. And there are only 3 integration rules here. There's only 3, because the only difference between these 3 and those 3 is that these all are negative and these are all positive. But when we integrate, we can take care of that through our constants of integration. Okay, there's no reason to worry about that constant multiple. I just put a negative. I actually just put a negative in front of it, and then voila, I've got my answer for the other 3. Okay?